Bismillah ar-Rahman ar-Rahim. Dear students, my dear students, dear followers, as promised, I will solve in this video this equation. So solve in R this equation. Here we mean by E the integer part. So there exists a unique n from Z such that x is equal to n plus r, such that r strictly less than 1 and greater or equal to 0. Let us here denote r. Here we are representing just r. So r moves from 1 to 0, and I will once again allow myself to do this to symbolize that r cannot be equal to 1. Since here we have 5, this is the trick. Since we have 5x, so we will divide. Why? We will divide this to 5 remarkable sub-intervals. Here, 1 over 5, 2 over 5, 3 over 5, and 4 over 5. Why we divide these to 5 sub-intervals? Because we have 5x. And if we suppose that here we have E for x, we will consider also 4 sub-intervals. This is the trick. What we get? We get, since we have this, so E of x is equal n, and so 4e of x is equal to 4n. And e of 5x of 5x, this is equal e of 5n plus 5r. And using a well-known formula, it is proved somewhere. For example, in my channel, integer part playlist, we have e of p plus x. This is equal p plus the integer of x. P belongs to z and x in R. So we have this formula. We will use it here. We get what? We get 5n plus the integer part of 5r. This is the second equation. So our equation takes the form 5n plus integer part of 5r equal 4n, which is equivalent to integer part of 5r equal minus n. So we will solve this equation by taking into account the fact that r belongs to this possible 5 sub-interval. First case. The first case, if r is less than 1 over 5 and greater or equal to 0. So this is the first case. We are here. From this case, we need to consider 5r. So 5r is less than 1 and greater than or equal to 0. And by the way, the integer part of 5r in this case is equal to 0. We need to solve integer part of 5r equal to minus n from this side is equal to 0. So n is equal to 0. If r belongs to 0, 1 over 5, the integer part of 5r is equal to 0. This means n equal to 0. And by the way, x is equal to 0 plus r. But r, verify this, which is less than or equal 0 plus 1 over 5, strictly less than 0 plus 1 over 5, and greater than or equal 0 plus 0, which means that here the solution is 0, 1 over 5. So the solution is 0, 1 over 5. Sorry. R is 1 over 5. So the solution is 0, 1 over 5. Yeah, this is solution S1, the first one. Yes. The second case, we suppose that R is less than 2 over 5 and greater than or equal to 1 over 5. This means that we are here. R belongs to this sub-interval. From what? This implies that 1 is less than or equal 5r, strictly less than 2, which means that the integer part of 5r is equal to 1. And we need to solve e of 5r equal to minus n. This means what? This means that this implies that n is equal to minus 1. Why? Because the integer part of 5r equal to 1 and we are searching n equal to minus n. And x, we are here, x is equal to minus 1 plus r, which is less than or strictly less than or and greater than or equal. N is minus 1. And r in this case is 1 over 5. This is the lowest bound. And the greatest bound is 2 over 5, which means minus 1 plus 2 over 5. This is x less than minus 3 over 5 and greater than or equal minus 4 over 5. If we times x by 5, yeah, this is, if we times x by 5, we get, this is x. I don't need to times x by 5, but we find x, and in this case the interval, this is the interval. The interval is minus 4 over 5 and minus 3 over 5. This is as 2. and this is as 1. I mean, if we times x belonging to 0, 1 over 5 by 5, we get 0, 1, so the integer part is equal to 0. And from what? Here we have 0, and here we have 0, and we have 0. In this case, if we times x, which belongs here by 5, we get minus 4 minus 3. The integer part is minus 4. And the integer part of x, in this case, the integer part of x is equal to minus 1, and minus 1 by 4 is minus 4, minus 4 equal to minus 4. The third case is this one. If r is less than, greater than, or equal, less than 3 over 5 and greater than or equal to 2 over 5. If we times by 5, we get 2 less than or equal 5r, strictly less than r. And by the way, the integer part of 5r is equal to 2, which implies that n is equal to minus 2. But x is equal to minus 2 plus r, and r is between 2 over 5 and 3 over 5, which gives us x less than minus 2 plus 3 over 5 and greater than or equal minus 2 plus 2 over 5. From this side, here we have minus 10 plus 2, this means minus 8 over 5, and from this side we have minus 10 plus 3, we have minus 7 over 8. And here we have the interval of solution is minus 8 over 5 minus 7 over 5. This is as 3. The third case, we are here. So for the third case, we have r, which is less than 4 over 5 and greater than or equal 3 over 5, which implies that 5r is equal to which implies that 5r is less than, greater than or equal 3 and less than 4, which implies once again that the integer part of 5r is equal to 3, which implies we are used to deduce quickly that n is equal minus 3 from the original equation, and we have x, which is equal n minus 3 plus r, less than, greater than or equal. R in this case is greater than 3 over 5. So this is minus 3 plus 3 over 5. And strictly less than minus 3 plus 4 over 5. This is equal and this is equal. From this side, this is equal minus 15 plus, so minus 11 over 5, and from this side we have minus 12 over 5. and the solution as 4 is equal to minus 11 over 5 and minus 12 over 5 and minus 11 over 5. For the final case here, this is the final case. For the final case, so this is S4. I need place here, sorry. I will take this place. Here I am at home and my whiteboard is a little bit short, not larger as the National High School of Mathematics. By the way, I am Professor Muammar bin Bashir from National High School of Mathematics. The last case, so we take here R, which is less than 1 and greater than or equal 4 over 5, which implies that 4 is less than or equal 5R strictly less than 5, which implies that the integer part of 5R is equal to 4, and by the way, n is equal to minus 4. X is equal to minus 4 plus R, which is less than, strictly less than, and greater than or equal. Minus 4 plus the least one, 5 over 4, and here we have minus 4 plus 1. This means minus 3. This is x greater than 20, minus 20, so minus 16 over 5. And the last as 5 is equal to minus 16 over 5 minus 3. So as a final solution, the solution as a final solution of this equation will be solution of the equation 5x equal to 4 integer part of x is given by as equal. This is the least one, minus 16 over 5 minus 3 union. This one minus 12 over 5 minus 11 over 5 union. The next one minus 8 over 5 minus 7 over 5 union, minus 4 over 5 minus 3 over 5 union, 0, 1 over 5. This is the final solution. So we need just to be patient, to go quiet and with confidence. I hope that all this is true. I am a little bit tired. Thank you very much for watching. See you inshallah next time.